Hey everyone, welcome to this new Tinkerine segment that we're starting. It's going to be called TinkMakes. Essentially, this whole series is going to be about us making something. So Tink makes blank.
Something.
Yeah. Well, I'm going to be your host today, Andy.
I'm Eugene.
And today we are going to be starting our first episode with coming up with a video dolly.
Well, I mean, we have a video dolly.
Yes.
For anyone that has operated a video dolly in the past, and you don't have the most steady of hands.
Yes, essentially for me, every time I'm sure everyone has seen our other productions. Sometimes I'm not very satisfied with my panning shots in the other series. And especially when you're pushing, you're just like, oh, I can't keep the same amount of pressure on it. And then you go, ooh. That's the point that frustrates me most, and I have to start the pan all over. I don't know.
So the idea is we're gonna take 3D printers, we're gonna do something with the 3D printers on, I guess on the design side, just to get the mounting mechanisms and stuff. And then what we're also going to be doing is we're gonna try and get this thing to become a motorized dolly.
Yes.
So that we can get the most consistent shots every single time, so that we don't ever have to worry about pressure and control and speed and all that. We'll lose the manual functionality probably.
But automation is the way to go.
I probably agree with you on that. Consistency is the key here. So I guess first project, motorized dollies.
Yeah, so we'll go right into it and show you guys what we did.
Cool.
Hey guys, we're back. It's been a couple days since we actually started on this project.
Yeah, we've actually spent the time with the slider itself. We've pulled some dimensions from the slider for the ones that are critical for this particular model. And we've actually designed some 3D models and printed them out as well.
Yeah,
as part of that flow.
So right now we're going to show you what kind of dimensions that were critical to us, and we'll show you what we measured. And then we'll start assembling afterwards.
Yeah, the idea is to put everything together and, well, give it a test run and see how it all works.
Yeah.
Cool.
Well, let's get started then.
Yep. Okay, so some of the key critical components that we pulled, there's 4 screws here for all the mounting components that go on the side, the idler bearing, and then the electronics. And then on the actual slider carriage itself, there is a dimension that we pulled for where the belt actually clamps onto it. So pretty simple dimensions. Otherwise, that's it. Yeah, so the dimensions is right here, and then the distance of this hole to the edge. And then we got to figure out what the screw size for that actually is as well. Okay, so we're about to put this bottom fitted 3D printed part on. We've got these bolts that the 3D printers use that will actually magically fit. But one thing is when we started fitting this on, due to all the tolerances, we actually have to cut these bolts in half so that they don't protrude and prevent the cameras from going in. So, off to the grinder we go with these, and then back to assembly.
So we have everything assembled now. It's also hooked up to a power supply. And I guess we'll do our first test shot of this new motorized Dolly.
Yeah, assuming we plugged everything right, which I believe we did. Honor's yours, Andy. Go ahead.
Okay,
I think the power supply needs to be turned on first.
Oh, let's turn it on.
Any of these guys would turn the direction.
Yes, so let's go that.
Is that full power?
This is full power.
That doesn't move very fast.
It seems very slow.
Okay.
If we...
I think we have some adjustments to do.
Yeah, and this side, the belt is actually coming off of our initial bearing.
The idler.
Yeah.
Okay, well.
Significantly slower when it goes.
Hey, but the good thing though is
it works.
We can change directions and the simple electronics work decently well. Okay, so I think we have a little bit of adjustment to make. I think we can go for a bigger pulley on this side.
Yeah.
And then on the other side, instead of a bearing,
we'll use probably a motor pulley for a belt to sit on.
Yeah, and for those that are wondering what the component is, I mean, everything is kind of stuck, so I'm just gonna move this ever so slightly. That pulley right there, the belt as it was moving was sliding off.
Sliding off.
So we'll change that into a pulley that's not set, so it can still rotate on the shaft. And I think we may have to remount one of the pulleys for that, but I think afterwards everything should sit nice and tight. And
you don't think our pulley sit on this rod, this size of rod?
Yeah, we may have to just drill it out with a drill bit or something.
We're just gonna take probably one of the pulleys from our 3D printers that we have here.
Let's do it.
Try it out.
We'll be right back.
Yeah. So we actually found some pulleys around the warehouse that used to be our 3D printers. There's this one which we're gonna use for the free bearing side, and we're going to be just taking off one of our 3D printers.
Yeah, and then this actually came off of a first generation Ditto. And it's a bigger pulley. It should give us more torque, and actually it should make it move faster. So we're just gonna swap it in and give it another test.
Yeah, so cool.
Okay, let's fire it up. Hey, it's moving pretty well, Andy.
Way faster than before.
Yeah, try slowing it down and see how slow of a crawl we can get it to go. Well, I think that's perfect. I think that gives us so much flexibility in terms of our video shots. The pulley on the other side is still kind of sliding off a bit, but I think we can probably adjust that by just having a top constraint put in, and I think we're off to the races, really, to be honest.
Well, as the slider goes, it'll probably just sit on the sweet spot. So we probably might not even need to put a constrictor there at all.
Sorry, I just really want to see it move. And well, I think this, you know what? This worked. There's an interesting little thing that came out of this. Because everything is offset a little bit in terms of its distance away from the foot, the main sliding carriage, that guy there, actually is a lot more serviceable because we can just take it right out without having to undo any bolts. I think, how about time for a B-roll with the new slider?
We'll try it out.
Let's give it a go. Okay, so Andy, the
project's done.
I think the project is at a stage of mostly complete. There's a couple things we do want to do to really finalize and finish this, make it portable. One, a battery bank of sorts that we can just bolt on, carry away, so we don't have to plug it into a power supply and have it run off an AC adapter of sorts. And then the second is, I think we need to go back in and just Loctite everything.
Yeah, just to make sure everything stays.
Yeah, one
in its
last
place.
time of just Loctiting everything down with, I don't know, whichever strength Loctite we have. And then it will then be permanent. This guy no longer moves around by hand, and so everything is going to be controlled by the electronics now.
Yeah, which I find absolutely awesome. I don't have to do those pans anymore where I'm very frustrated with every time my speed or the friction changes along this thing.
Yeah. This was a really quick project. This did not take too long. There wasn't so many critical dimensions that we needed
to take.
And I think it's going to up your B-roll game. Some of the shots in the future projects will probably incorporate this to a certain degree.
A lot more steady and beautiful shots as we demonstrated.
Yeah, and the customizability, right? There are little interesting tidbits that came out of it. The fact that we can now service the sliding element really quickly because the 2D printed pieces just lifts everything off enough for us to do that. And I mean, we just transformed, what was this thing, like a $30, $40 slider into a,
could be a $60, $70 slider now with this controllable unit.
Yeah. One thing we did joke about as we were doing this is there's a lot of sliders on Amazon that are just mechanical manual sliders. This may be an interesting project to just take on and identify the top 10 sliders and build conversion kits for them, because it's not difficult. It's a quick project. In total, actual time invested, probably no more than about an hour to 2 hours worth of time. And Andy's gonna have more B-rolls to work with in the future.
And he's gonna be a lot more happy.
So there you have it. I think we're gonna maybe point to a couple of the components. There's, no sponsorship with any of these, but the electronics is simple to put together.
Well, there are some sponsorship from Tinkerine.
Well, we do have access to some of these components, and the rest of it was just Amazon parts or AliExpress or whatever parts, and they were probably $10 worth of extra components. Off to the races. Anyone can make one of these. Assuming you have access to a 3D printer at home or inside your library, inside your studio. Then making the components shouldn't take too long. So if you want to follow our tutorial on making this, you can also customize and make one for yourself. And I think there you have it. A manual slider that was wobbly at best turned into an electrical dolly, electronic dolly, or electrical control dolly with two-way directional switches that allows us to pan left and right to our heart's desire. So I hope you guys enjoyed this episode of TinkMakes, and we look forward to making more of these to share with you guys as they come. So just remember to subscribe, press the bell button downstairs, and also the subscribe button right here, probably down there somewhere. And then every time we release an episode, you'll be notified by YouTube that we released one and be on top of all our projects. So with that, we'll see you guys next time. Cheers.
Bye.
My head's cut off.
Yeah, your head.
Why am I so tall?